In this video, I'm going to show you our smart object system, which we can use with our other systems like utility AI and influence maps, or as a standalone thing. Let's take a look at the demo first. So there are two characters. One of them is going to the car, the other goes eats some food, turns green and goes to the car. When the car is full, it simply moves toward a destination. Basically, smart objects allow you to create objects which have their own behavior coded in them. So the character, instead of having the driving logic, just asks the world, is there any object which I can use to drive? Here, as you can see, we are asking for an object basically around ourselves, and the requirement which we are giving is that the object should have a driving behavior, and we are looking only just like 30 meters of radius. Now, we happen to have an object here which has a smart object component which has a driving behavior, which we define in this class. The driving behavior, smart object basically behavior, allows you to code for the times that an entity, which is an agent or whatever, basically claims that it wants to use the object, and also when it actually starts using it. So a smart object basically is defined by creating a smart object definition, which you can define like this. And then you can say how many slots a smart object should have. You should have at least one. And then you can have a position offset for the slot, which is basically where the slot is located. For the object, you can have a priority number, so the basically agent knows how good the smart object is, and you can say if the smart object should have an owner enforced or not. After you define something like this, which you already have, for example, as a car here with two slots, and also as a refrigerator here with one slot because it doesn't need two, then you attach these to a game object by doing something like this. For example, let's say I want to create another car, which is a flying car. Let's do something like this and attached a smart object component to it. We also want a driving behavior, and let's basically add this behavior. And the driving behavior should move pretty fast, should move upwards and forward, and the destination is like, let's say, decrease the upward a bit. The destination, instead of being the previous one, is at 30. Yeah. But we do not want the car definition, we only want one slot. So let's create a different definition called ship. A ship has only one slot and it's 1 meter above, and let's give it to the smart object. Now, if somebody wants to use a driving basically behavior, they can use this. Now the player should probably choose this instead of the other one. Let's move it to here. Now the player which wants to drive will choose to come to this if we increase its priority. So as you can see, without changing any code in the player, now I gave it a flying machine and it flied using it, and it really flied. So if basically the old destination was at 30 and on the ground, and we are like in the air, and the other is still waiting in its car to get full because the car will not move until both slots are full. And as you can see, the gizmos here, one of them is green, so it means it's not occupied. The other is red, which means it is like being used. If something is reserved, it will get blue. So for example, the fridge is here. When it's not running, it's white, but as soon as we start running the project, since the player reserves the fridge, it gets red, and then when it's being used, it gets blue, and then now it's free again, so it turns green again. So that helps you to debug basically. I hope this helps. And the priority of the smart objects, you have to use them yourself. So if the code doesn't care about them in your project, the system doesn't care about it either. Basically, the smart object system only registers all of the objects that you got and then allows you to find them, and then you choose which one to use. So in the code which I have here, let me see. What I'm doing is that I'm getting a list of smart objects to drive, and then basically if count is more than 0, I'm taking the first. So if I wanted to get the highest priority one, the most like quick way was to use order by. Then get the smart object component of the returned results, and then also its definition and the priority, and then use the first one. So it will always choose basically the one with the highest priority. And then here I could come and say, okay, the priority of a ship for doing stuff is 2 compared to a car, which is 1, because a ship is better. And you could set that dynamically in code as well. What else do I want to say? This code is available in the package for you to basically read and learn from, and it's documented, as you can see. The only other thing that you need to know is that the information which is returned to you contains all of the smart object, and also the results of the filter. And also you can filter by tags as well, other than behaviors if you want. So you can add tags on top. The filter result, what it tells you is that if this smart object usage, first of all, is supported, which should be true for the objects which are basically supported, and for those who are not, it will be false and you cannot use them. So also it tells you if a specific slot is reserved for you, because that slot has the behavior only. And if it's slot specific, it will tell you what slots support what you want. Because, for example, you could have something like, say, okay, I want to have this behavior like driving in my car, but also I want to have a slot specific behavior, which says the second slot, slot index 1, also supports, for example, eating. And then if you wanted to eat something, this object would have been returned to you, but it would say, okay, this is a slot specific uh, object, and you can only use slot 1 for eating. Let's say there's some food there, and you can imagine how good and dynamic you could make this, like if you wanted to. So if there's some food somewhere, then it will advertise itself. Or if there's like a car with a refrigerator, and then the refrigerator can contain food and advertise itself to the player, so he doesn't go to the kitchen of his house if he's nearby the car and the refrigerator is already there and contains food, and you can eat from there instead of going to the car and grabbing something and coming back. Of course, you can have other logic which basically describes how, when this should happen or that, but that's up to you. And this system will only tell you which objects are available and allows you to execute their behaviors on the agent. And there are only three functions that you can, like you can claim an object, and then after claiming it, basically you will use the object, and that's it. For example, here in the eating behavior, as you can see, I'm finding the object which have the behavior which we want, which is eat food. And then what I'm doing is that I'm saying, okay, give me the first object which have something to eat, and then I'm just getting a free slot index, and if it's not -1, it means it has a free slot. Then I move to it, and after I do that, then I call claim, and it will claim that slot, so no other uh, agent can claim that while I have it. And then I will eat after 1 second, just for demoing purposes. And then the eat behavior describes what should happen when I claim or when I eat. So it overrides the functions. So when somebody claims it, it will simply change color to blue, and then also moves the agent which wants to like eat from it, just for demoing purposes. When cleared, it changes the color and does another movement. And also when used, it changes the agent's color too. That's why the agent turns green when he starts eating, basically. And we've created a compiler. Because basically we cannot have 0 here unless we call to array, but we can call first. So the reason that our object, like the agent, turns green when he eats food is that the eat behavior does that to the agent. If you want, you can define an eat behavior which does something else. This wretched sheet didn't allow us to see that. So let's either disable it or decrease it. Let's decrease the speed for fun. Just let's say it moves at 0.03. So it's as slow as hell. Goes to the other car and waiting, and see that we are starting to move bit by bit, not so fast, but still. Okay, we should wait until the morning if you want to wait for these two. And That's it. I hope you use the package and enjoy it. It's available in our Ultimate Utility AI package and also as a separate package. And for the first 2 weeks, they both are 50% off. Like the Smart Object package is 50% off, and upgrading from that to the Ultimate is 50% off too. Have fun.